So my colleague and I attempted to provide a historical and climatological context for the megafires, the huge fires that burn through 10,000 acres or more in the canopies of southwestern forests. And we decided to do this by taking advantage of some of the extraordinary properties of the annual growth structures of trees, the things that most of us know of as tree rings. Tree rings grow annually based on the limiting conditions of the environment. So in dry environments, trees record the amount of moisture in the year before the tree grew. This is one of the ways that scientists can use tree rings to reconstruct year-to-year changes in weather patterns. They can reconstruct ancient climates. Tree rings are also really great recorders of certain types of ecological events in their history. In the case of southwestern forests, they are tremendous recorders of fires. This is a cross-section through a tree where you can see all the years of growth. This tree was 70 years old when a fire first burned around the base of the tree, creating a little bit of damage in 1722. And on average, once every decade, for the next 2 centuries, fires burned around the bottom of this tree, creating more damage, things that we call fire scars. So we know how often fires occurred around the base of this tree using the tree rings, which we can date to the year. This also lets us know that in 1898, fires stopped around the base of this tree. And this is a pattern that we see across the Southwest. That around AD 1900, fires cease in the Southwest. And so these forests have basically been without fires for more than a century. And so as fires are occurring in these forests now, these are happening in a very different way. The fires that burned through these forests in the past basically maintained a very open structure, because the fires along the surface of the ground, in the grasses, down pine needles and limbs, these maintained a very open and healthy structure. Forests like this in the Southwest were able to withstand long and severe droughts because they had no mechanism to take fire and take it into the canopy, to destroy the canopy the way the fires happen today. Today, of course, this is the consequence of fires. Right? Rather than cleaning out the underbrush and the down leaves and limbs and grasses, it is catastrophic. And the way this happens is by removing fire. So by taking the very frequent low intensity, low temperature fire away, you allow all of these young conifers to grow up and join the canopy. When they do that, they're all competing for water. They're all competing for nutrients. They're all stressed. So droughts and these types of conditions much more easily can have fires that cascade from these young conifers into the canopy, leading to these megafires. And we were concerned with whether or not this is something that's unique to contemporary conditions. Is this something that is unique to a world in which we are experiencing warmer temperatures and more severe droughts? Or is this something that would be anomalous without this last 100 years or so of human land use, of fire suppression, of widespread grazing? So we took the tree ring climate records and the tree ring fire scar records and combined them in a statistical model. And what this does is this allows us to look at the year-to-year patterns in climate and the frequency of fires. And there's a really strong statistical relationship between 2 wet years that produce all of the grasses and fine fuels that carry those frequent surface fires, and then a dry year when the fire happens. And we can model that using the long-term tree ring climate reconstructions over more than 1,000 years. And this has allowed us to try to look at whether or not periods that were warm and dry, like today in the past, had different fire-climate relationships than those of the last few hundred years before human-caused global warming, a period that we call the Little Ice Age, when most of our tree ring fire scar records come from. And it turns out that the warm and dry period about 1,000 years ago is identical to that from the Little Ice Age, meaning those patterns of wet, wet, dry happened just as often 1,000 years ago as they did during the Little Ice Age. And what this means is that in the absence of widespread grazing by sheep and cattle and active fire suppression, we would still be having frequent surface fires in these forests. So it's a combination of the severe droughts associated with climate change and the 100+ years of land use that have created the conditions where forests can now burn like this in the Southwest. And our research is the first of its kind that has been able to use the year-to-year resolution of tree ring records to look at fire climate patterns over more than 1,000 years in southwestern forests.